2%. Nice. All right. Yeah, and yeah, thank you for being flexible.
No,
Right.
no, I'm sorry. Oh, you're
Yeah.
doing physics?
Yeah, I thought we were doing physics. Yeah. How did you get on?
Oh, huh?
How did you get on with the questions I sent you for homework? Were you okay doing those questions? Did you have a go? And do you
Actually, oh, I guess I forgot to tell you.
yeah.
The teacher
Mhm.
was gonna get his booster shot when we were
Okay.
gonna get our exams.
Okay.
So he changed it to Friday, the
Okay.
last Friday. So I already presented it.
So you have done the test already?
I got fourth place.
Oh, you got the highest mark.
No, fourth place,
Fourth,
not
that is
first.
so good. Fourth
Oh,
is so
thanks.
good. So you're not having a physics test then?
I already had it.
Okay, right. Okay. So I didn't know what you wanted to do then. I literally just thought, okay, you want to do physics. So I prepared
No,
for
no, it's
physics.
fine.
But
I
I'm
appreciate
just
it.
trying to see. You didn't send me any material. No, no, you
No,
didn't.
no, it was my fault, completely.
Okay, okay. So then, Sayaka, tell me what you want to cover then. What do you want to go through?
I was thinking of doing logarithms.
Okay, okay. That's fine.
I have exercises. If you want, I can send them to you.
If you can send them, that'll be awesome. Then we've got some resources we can work with together.
Yeah,
That would
I'll
be
send them to
absolutely
you.
awesome. Okay, great stuff. Okay. While you're doing that, I might, while you're sending that off, let's go down here. And
I
uh,
send it to you.
thank you. So let me just find how time venturing. Uh, there. No, let's try to look through here. One moment. I'm just going to open this up. So you've sent it to my email. I'm just checking if I've received it. Hasn't yet arrived.
Oh, he hasn't?
No, I'm just waiting. I'm just refreshing my page.
Yeah.
Yes. I see it now. Okay. I'm going to download it and then we're going to bring it into the board. All right. So
Okay. We have done another one, but I don't know where it is. So
that's okay. That's okay. Don't worry. Don't
it's
worry.
just logarithms is very like the first exercises are very easy, but then it just becomes insane. I don't know how to do them.
Okay, that's
And the
fine.
ones that I sent you, I think I can do them. But from
Okay.
there, he gave us like an exercise that was really difficult. And I
Okay.
don't
I'll
know.
tell you, I'll tell you what we're going to do then, okay? Because you've already got these rules. A log a to the power of log a to the m. Right, right. That's absolutely fine. So what I'm going to do then, Sayaka, I'm going to get some challenging logarithm problems for us to work through together. Is that okay for you?
Yeah, that's fine.
Yeah. Okay, so I will do that. So just bear with me just one moment and I'll get those questions. Right, here we go. And logarithms. Just laws of logarithms. There we go. Fantastic. So do you want medium? Do you want hard? Do you want very hard?
Medium hard.
Medium hard. Okay, that's fine. Let's start off with some medium questions then. So just as a warm up then, here we go. Start off with this one then. How do you say the answer to this is?
Log A plus log 327.
Let me get my notebook.
Without calculator or with calculator?
Just normal calculator.
Oh, okay.
First, I have to use the rules, right?
Yep, absolutely.
I have the rules in a picture, so I have to check it. Okay. So log 24 log 24 plus log 327 minus log 44. Okay. This is minus 1. 24 is over log 2 plus log 27 over log 3 minus 1. But doesn't that just make it bigger and bigger and bigger?
No, there's an answer for this. You should already get one number at the end of this. So in other words, this is equal to something.
Without using calculator.
You can do it without a calculator, yes. Or you can use a calculator, whichever.
Okay.
But the numbers are very friendly, so you don't need a calculator. But if you wanted to, you can still use it.
Oh. Okay. Log 4 over 4, log 4.
Yeah.
Isn't that just 1?
Yeah, correct.
But the log 2 and 4, you just transform it into a division, right?
Yeah.
And then from there you transform it into like this minus this.
Correct.
Oh, okay. I had a question about that. So
that's fine.
Log 4 minus log 2 plus log 27 minus log 3 minus 1. I got log 26 minus 1.
Okay, log 26. Okay, so let me just run you through some fundamentals on logarithms, that the way you need to think about them, yeah? Because I think you already have an idea, but because maybe you've just started learning it, you've not yet consolidated some ideas yet. So if I wrote something like this, log to the base a of b is equal to x, yeah? There's a little rule.
You can just change a over x is equal to b.
Absolutely. A to the power of x, you're right. So b is equal to a to the power of x. This sometimes some people call it the bullying rule, like to bully, because when the a goes up here, it bullies, it pushes the x away, it pushes it away, and it goes to the top. And now the a takes over. It's like it bullies the x. So this here, exactly. Now this here, log 2 to the 4. So basically we're saying what is, so let's say we don't know what this is.
Oh, so
So
like
there's a
that.
certain number, 2 to the power of something is 4. So what is that something? So here, this here would be 2.
Yeah.
Likewise,
Oh, so like that.
log 3 to the 27 is saying 3 to the power of something is 27. So what is that thing? That's 3.
3.
Yeah. Also,
That is
log
1.
is 1, correct. So we have 2 plus 3 minus 1.
Oh, so like that. Oh, I was
Yeah,
just doing like the division and then minus, and then I just
I
got it.
know, timesing and everything. So now this is the fundamental way of how you think about logs and how they work. Are you okay with that?
Yeah.
Excellent.
I knew the rule, I just don't apply it.
I know, but I think when you just started, because there's so many rules, it's very hard sometimes to know which rule to apply. But once
Yeah.
you've done enough questions, then you're going to begin to know which rules to apply. And the thing about logarithms is that you can be so good at them today, like really, really, really good. And then if you don't practice them for 1 month, you're not going to remember the rules. So then you have to remind yourself of the rules again. Okay. So because they're
I
just
have
too
a
many.
question.
They're quite a lot of rules there. Right. Here's another one for you then for you to try.
Okay. Just a quick question.
Go
What
on.
is logarithms? I never really understood. He told us something about like there's a natural thing like log e that is ln. I
Yeah.
don't even
Okay.
understand that. I
So,
was so
okay.
confused.
Yeah, that's absolutely fine. So if I just insert a page, a blank page before current. So logarithms really derive from what we call exponentials. So to understand logarithms, we need to understand exponentials. So that's where it's coming from, okay? Now, what is an exponential? An exponential is any equation that looks like this. Y is equal to a to the power of x. That is what an exponential looks like. Now, a cannot be a negative number. That's just the rule we use, okay? Cannot be a negative number. That's just the rule when we're looking at functions. So if you draw an exponential graph of anything that looks like y equals to a to the x, what does this look like? Well, it looks something like this.
Wait, I have a question.
Go
If
on.
a cannot be a negative, then what if the log is like log minus 4 over
Yeah, try and
3?
do that in your calculator. Do log minus 4.
All right, wait a minute. I have to.
That's fine.
Log minus 4. Oh, non-real answer.
There's
Oh,
no
I have
answer
no
for it.
idea. Let me add it there then.
Can you see that your calculator doesn't give you an answer for it?
Yeah.
Exactly. So this is why I said, A, it's part of the rule. A cannot be negative.
I had no idea.
But it's okay. That's why we learn these things. So what does this graph look like? This graph looks like this. Well, if you just trying to think of the values, yeah. What do you think this graph would look like? Do you agree? Or just have a go. What do you think it would look like for us? So imagine you were plotting a graph of, just to make life easy, y equals to 2 to the x. Another one is going to be y equals to 5 to the x. So now you can draw on my board what do you think the graph of y equals to 2 to the power of x and y equals to 5 to the power of x, how they look like if you sketched them on this graph?
I have no idea.
No worry. And what you normally do, if you don't know what the graph looks like, it's always a nice little idea to just draw up some values so that you can have a feel for what they do. So we can have values here where we're going to vary x and we're going to see what y becomes, okay? So we can just start off with a few. We can make x equals to, we can start off with -2, -1, 0, 1, 2, and maybe 3. So what are the values going to be if we just look at the first part, y equals to 2 to the x? So when x is -2, what is y?
Oh, so like that.
Yes, like
Oh, I
that.
just completely forgot about it.
That's absolutely fine.
Let me write it. Press it.
Mhm.
Oh, okay. Now that makes sense. When my 2 is it gonna be minus something?
Would it be minus? So what this means then, if we put this one here, when x is -2, so the first one you're doing here is 2 to the power of -2. Yeah.
Oh. It will just be like 2 on the power of 2, and just the answer will be just changed to minus, right?
No. So, okay, I see there's another little part you're missing here. So laws of indices, can you remember laws of indices?
There's
So
a
if you
lot
have
of things that I
something,
haven't.
that's okay, don't worry. So if you have anything, say, I'll do this one for us together. 2 to the -2. What this means, it means 1 over 2 squared. Okay? That's what 2 to the power of -2 means. Because if you use the laws of indices, it means it's 2 to the power of 0 divided by 2 to the power of 2. Now remember laws of indices, Sayaka, if you have a to the m divided by a to the n, this is the same as a to the m minus n. Do you remember this? Yeah? And anything to the power of 0 raised to the power 0 is 1. Any number raised to the power of 0 is equal to 1. So here, if we use the same law, 0 minus 2 gives you the -2, and then you write the original number. That's why this 2 to the power -2 is the same as 1 over 2 squared. Are you okay? Because 2 to the power of 0 is 1. Any number raised to the power of 0. So are you okay with that?
Yeah, I think so, yeah.
Excellent. So this here would be a quarter.
0.5, 25, 0.25.
Yeah, good. On the next one.
That would be, wait a second. 1 over 2.
Yeah.
And that would just be 0.
Not quite.
1.
Remember what I just said? Correct, because anything raised to the power, can you see this part here?
Oh, right,
Any
right,
number
right.
raised to the power of 0 is equal to 1. Any number, because it means if something has been raised to the power of 0, it means you have divided it by itself. So if I have a to the power of x divided by a to the power of x, using this law, this means the final answer is a to the power of x minus x, which is a to the 0. And we know that this must be equal to 1 because you're dividing something by itself. So anything raised to the power of 0 is always 1. You okay with that?
That makes sense.
Good. Okay, next one.
2.
Yeah.
4.
Yeah.
Wait.
Good. So what do you reckon the graph is going to look like?
It's just the dots, the like x
Yeah.
minus 2 and y is gonna be like this, and then it's gonna be -1.
Yeah.
No, wait. The -2 minus 1. Yeah, just like that. And I don't know how to explain.
No, but you've kind of you've kind of got it, and that's why it's called an exponential. Yeah. So it will start off very small. In other words, as x gets more negative, the numbers get very small. Half, quarter. If you had -3, it's going to be -0.125. So as x becomes more negative, the values of y become really tiny. And we know that it cuts the y-axis at 1. So this graph is going to look something like this. Let's use this here. It's going to do something like this. Okay. Now, will it ever touch the x-axis?
No, I don't think so.
Very good. It never, ever. It gets close, but never touches. Yeah. So even if we could have -100, but even then, 2 to the power of -100 is not 0. It's a very, very tiny number, but it is not 0. Very good. So this is what 2 to the x might look like as a rough sketch. So we're happy with that. Excellent. Now I want you on the same axis to predict, have a go at thinking what y equals to 5 to the power of x would look like. In other words, yeah, have a try and think and tell me what it would look like, 5 to the x. You can tell me and I'm gonna sketch it on this same graph.
Okay, then let me think for a second. Well, it will still be in 1. Like it will still pass.
Very
in
good.
1.
So all exponentials of this nature, they all have to pass through this point. You're right. So now the question is, Sayaka, is it going to do this? Or is it going to do this in the blue dot? Which of these is going to be y equals to 5 to the x? The blue dot or the purple dot?
The purple one.
Very good. Yeah, why is it the purple one?
Because the numbers are like bigger.
They're getting bigger very, very quickly. You're absolutely
so it gets
right.
smaller, more also quicker.
You're spot on. So this here would be y equals to 5 to the x. Right. So now that you've understood this idea, there's something known as a natural log, or sometimes also referred to, if you like, as Euler's number. Okay. Euler's number is given the letter E.
Yeah, log E.
Absolutely, Euler's number. So instead of writing like how we've written y equals to 2 to the x, y equals to 5 to the x, this looks like y equals to e to the power of x. This e has a value.
Yeah,
What is the
was
value of E? Any idea?
1.27? Was it 1.27? It was, I
Yes.
have it here.
Yeah, you can punch it in your calculator.
Oh. No, but I have it. I have it. I should have taken notes. I think I have it.
Huh? One moment, I just need to reach for my calculator.
Yeah, it's fine. Oh, it was 2.71.
Very good.
I just mixed the numbers. I said 1.27.
Yeah, that's fine. That's fine. You're absolutely fine. So 2.71 is this number E. That's a very important number because a lot of things in nature are modeled after Euler's number and this exponential.
It
So
was like
sometimes it's known as a
time.
natural logarithm. Yes. So it's natural because it occurs in nature. That is how it was derived. Now it's also got a very, very special property. This y equals to e to the x. It's got a very, very special property in that. If I put a blank page after current, here we go. So if you plotted y equals e to the x, of course, it's going to look like the others. It's going to pass through 0, 1. We know that. But then it's got a very interesting feature. So if you try to find the gradient at any point, the gradient at any point is always equal to the value of whatever e to the x at that point is. So gradient, remember, is the steepness of the slope. Remember that? So you draw tangents. Remember finding gradients at slopes?
Not really.
Okay.
But I kind of get what you mean.
You know what I mean, exactly, because it's gonna. This is gonna come into differentiation. When you start learning about differentiation, you're gonna start looking at gradients. So it's something you told me before. So it's literally just how steep a slope is. That's what a gradient is, and you would have done this just to give you a reminder. You'd have been given a straight line. You use 2 points, and you find the gradient, how steep it is. But here you're finding the gradient at specific points, because this gradient is changing, the steepness is changing. So if this, for example, has the value of, say, let's just make this 2, it means the y value here would be e to the power of 2. If this here was 3, the y value would be e to the power of 3. Okay. If that's 4, that value there would be e to the power of 4. Now the slope, the steepness of this line is also e to the 2 at that point. So it's a very interesting graph. Steepness is also, or in other words, the gradient is also e to the power of 2. Here, the steepness of the tangent, so gradient of tangent, I'll say. Likewise, the gradient of tangent here is, or which we call m. M we use for gradient. So I'll just put here, m stands for gradient. In math stands for gradient. Why does it stand for gradient? Because y equals to mx plus c. M is the steepness. So m here would be equal to e to the 3, and the m there, the steepness of that red line, would be equal to e to the 4 at that point. So it always takes the same value. Whatever the y value is also the steepness. Now there's not many curves that do that. So it's a very, very special curve, okay? So that is Euler's number. Now, where do logarithms come into play? The first thing I want to tell you first is I want you to appreciate this idea of what is known as an inverse. So whenever you have a function, So functions can have an inverse. Now, what is the inverse function? Any idea what an inverse of a function is?
It's going to change places?
Yeah, sort of. So if you had an equation, okay, here we go. Oops, no. So you're nearly there. I think I sort of understand what you mean by when you change places, blank page after current. So if you have something that looks like y equals, I'm just making up a function, 5x plus 3. Yeah. What this instruction means, if you think about it as a function in terms of inputs, we have a box in here. And this box, when we input, so input number, first we need to times by 5. The answer, add 3. And then this now gives us our output. So I've written this equation, but in terms of a function, like, like sort of what's going on. So if I had an input number here, which was 3, times 5 would give me 15, plus 3, my output would be 18. Now the inverse of a function says, what is the equation I would now use if I knew that my output is 18? How can I find my input? That process that you're going to do is what we call the inverse. So you can see here, if I was adding 3, to go back this way, I need to subtract 3. That's the first thing I need to do. Then the answer, what should I do with the answer? I should divide by 5. And now this will give me my input. So this is the reverse. So it's the reverse process. The other way to think about it, and this is, and I know it seems like this is not related to logs, but this is now you're going to understand where logarithms come from. So the other way you could think about it is that if I had to write an inverse function, if this is the function for y, the inverse, you can think about it as replace the y with the x. Yeah, like this. And then you make y the subject of the formula. So then you're going to do x minus 3 equals to 5y. Therefore, y is equal to x minus 3 divided by 5. This is what you call the inverse function.
Okay, let me copy.
Now, that's fine. Are we okay so far?
Yeah.
Good.
Can I go to the bathroom quickly?
Yes, certainly.
Oh, thank you.
That's fine.
Thank you.
Absolutely fine, Sayaka. Okay. So good that you understand the inverse function. It is the function which helps you. If you know what the output is, it helps you to find what the input was. 18 minus 3, 15 divided by 5 is 3. So 3 would have been the input. Now, if we tried to plot
Oh.
both these functions
Wait.
go on.
Is logarithms the inverse function of the,
Of an exponential.
yeah.
Correct. Absolutely.
Oh,
Now, let's try and think how the function is related to its inverse function. So if I drew page. So if I had, let's look at these two equations just that we looked at, nice and easy. Y equals to 5x plus 3, and the other one is y equals to, what was it again? X minus 3 over 5. Let's try and plot these equations on a graph, because these are all straight lines. These are all equations of a straight line. So these are straight line equations.
are they gonna be a reflection?
Very good. Excellent. That's exactly what I wanted to hear, Sayaka. And where will they be reflected in? So let me just quickly sketch y equals 5x plus 3. So this one, of course, has an intercept of 3. It cuts at 3. And then this side, it cuts at 0 minus 3 over 5, or minus 0.6. So it looks something like this. Oops, let's use a different color. It's going to look something like this, a straight line. So this here is y equals to 5x plus 3. So where will this one be now? Can you tell me how it will be? It will be a reflection, you're right, of this line. But where will this line be reflected in?
The y-axis?
Not quite on there. So
X-axis?
actually, no, this one is a really tricky one, actually. The inverse is always reflected. It's a reflection of the original function, but it's reflected along the line y is equal to x.
Oh.
Always the inverse is always, you look at the original graph and then you reflect it. So you draw the line y equals to x, and then you reflect it. So if I reflect this line, yes, say imagine I put a mirror there, then this point will now be here. It's reflected.
Oh, that makes more sense.
Okay, good. And where will this be? Well, this will now be on the side of things. That makes sense? Okay, my scaling is not quite right, but you kind of get the idea.
Okay, let me
This
quickly.
here now would be the function y equals x minus 3 over 5. And this is the inverse. So this is reflected. So original line, original function, reflected on y equals to x mirror line all the time. So if you have an exponential now on the same page here, well, an exponential, anything y equals a to the x will look something like this, and we know it's going to pass through 1. So I'm not interested in any other points. I'm just going to put 1 here, and that's 0. This now here, if I draw the line y equals to x, so this is the function y equals to a to the power of x. The inverse of this, I reflect in the y equals to x line. And this will now look, that 1 will be there. There's that 1. And what will this look like? It's going to look something like this. It's a reflection, isn't it? Can you see that?
Yeah.
This now, this function is a log function. And that's where logs come in. It's the inverse of an exponential. So far, so good.
Yeah.
Excellent. Right. So that is the relationship between an exponential. Now, if you plotted y equals to e to the x, however, so let's look at this one now as our final idea to explore. So if you had, instead of just any odd exponential like what I did here, where I just choose a random exponential, I just said y equals to a to the x. This time we want to focus on y equals e to the x. But what's that going to look like? So there you go, that's your 1 there. And so of course, still got to do the same thing and do that. So that's your y equals, e to the x. If you reflect this now, of course, it's not going to look any different to what we've already seen. Oops, different color. This function now, the inverse is ln of x. ln. ln. Now, this is what we call a natural log. So you see this written as L and an N. Have you seen this yet?
Yeah, I have.
Good. So that is the relationship. So you can either work in a base of the natural log base, or you can work really to any base as long as you apply the rules. So we're going to have you had any questions involving the natural log of x?
Oh, yeah.
Oh, good. Oh,
You haven't
fantastic.
told us that is the same as just using log?
Yeah,
Or-
exactly. The rules are the same. You're absolutely spot on. In which case, I'm going to throw in some questions with natural log. I wasn't sure that you'd done it. So good. In which case, then let's crack on and do a few more exercises to make sure that you get really strong at this. So do you want to have a go at this one here? Now, this here is just a case of applying the laws. So see how you get on with this one here.
Thank you.
It's okay, you're welcome.
Okay. Oh my God. Okay. Teacher, can I ask how many hours do you use to study?
Sorry?
How many hours do you, when you were studying for like university? or
Oh,
high
when I
school?
was, oh, wow. A lot of hours actually, so I can be very honest with you. What I used to do generally is I used to, like, as a routine, now not everyone can do this, but I just used to happen to do it. I would be asleep, I'd be in bed from about 8 o'clock, and then I wake up at about 1 o'clock, and then yeah, 1 o'clock in the night, and then I work until about 4 in the morning. So do like 3 hours late in the night because it's quiet and your brain can think more because there's no noise. Everybody's asleep. And then I then have, go to sleep. And then of course I have a little short nap, and then I do karate and things to get ready for the day. And then in the day, I would just literally, because I've done so much work already in the night, I normally used to finish school like you around 3 o'clock. And I'll give myself maybe an hour and then do another 2-3 hours. So in total on a weekly basis, you're probably talking about 40 hours of work extra outside of school, which is doable.
Wow.
Yeah. Is that about what you're doing at the moment? And I mean, I know you're very busy. Like, look, IB is one of the hardest courses. Well, it is. I say one. I think it is the hardest, to be honest.
You took the hardest?
No, I'm saying you are taking the hardest because you're doing IB.
Oh yeah.
Absolutely, absolutely. So you
Well,
know,
I still haven't done the DP. I'm still doing MIP. Kind of
yeah,
concerned because I have some
but when you
classes there.
finish, you're gonna have such a good foundation, Sayaka, so that you can actually do very well in your IB. And like I said, if you want us to do some of the topics in advance, that'll be easier for you because
Yeah.
the secret for me, Sayaka, what I used to do, the reason why it was easy for me, a bit easy, I always used to do work that was 1 year ahead of me. So when I was in year 8, I'd finished all the year 8 stuff I was doing year 9. When I was in year 9, I was doing all the year 10 stuff. So I was never like everything I was listening in class, I would have heard it before. I never learned anything first time in class. I learned it before I went to class. Yeah.
Oh.
So by the time my friends were getting ready for exams, I'd done all the exams, everything I'd finished. And when I was doing advanced studies, I was already doing university work. So I always think it's easier if you stay a step ahead, then school doesn't become as challenging. It's very hard to learn something today and be good at it. But if you've learned it 1 year ago and your friends are learning it today, you're going to be a much better student because you've seen it before. It's
Oh.
easier, yeah.
I think
Exactly.
I'm just gonna have just one session of just you telling me what to do.
Okay, that's okay. Don't worry. I will definitely give you some tips. Don't you worry at all. Okay. I know that you want to
Yeah,
do
actually,
well.
can we leave some time this next session? Not this
Yeah.
session. I mean the next hour.
Yeah. That's absolutely fine.
Because I've been really freaking out about all of this.
I'll help and that's the reason why, whenever you find like things are seeming overwhelming, like you should always talk to people around you, your family, your tutor, me, your teachers. You should never feel that you need to work out every problem by yourself. That's why you've got a network of people around you. It's to help your life and help you
Thank you.
make decisions easier.
Thanks.
You're welcome.
I'll just make this one then.
Okay, that's fine. When you're
And
ready,
then
say I can have a go at that one. Remember, you're applying the rules on this one, yeah?
okay. All the rules. I'll use most of the rules. Log A plus log A B is gonna be okay. Log A B. Okay, I got it.
And I managed to get there in the end.
Yeah,
Okay,
because
so
when you have 2 log AB,
yeah,
2
log
log
A to the A for 1 plus 2 log AB plus 3 log AC. Good.
and 2 just goes up. It's log
Absolutely
AB.
right. So log AB squared log C cubed. And of course, this is log A to the base of A. So then it's adding, isn't it? So you're absolutely spot on. Nice, a nice little problem. Not a lot involved in this one, but it's good that you can apply the laws.
It looks so difficult. I thought it was gonna be
Exactly. I know it looks intimidating when all these things come in. So some of them look scary, I understand. But, once you start applying the laws, you realize that, what about solving this one then?
Solving equation log x if 5x minus 6 is equal to 2. Okay. We haven't seen multiplication with logs.
No, there's no law for multiplication of logs. Sorry, there's no law that exists on that one. But it's a good question, Sayaka.
Then how do I do that?
You mean this one here? Oh, which multiplication?
Isn't log x multiplied by 5x multiplied by?
No. So this thing here is in base x. So it's log of the base x of, you can think about this as one number. This is like me writing log
Oh,
2.
that is B.
Yeah, correct. This is one number. Okay,
Oh,
no problem.
okay, that makes more sense.
Good.
I was wondering what happened. Okay, that makes more sense. Okay, okay. Log 5x minus 6. X. I'm supposed to find what is X?
Correct.
Hmm. I got stuck.
That's okay, don't worry. So remember, the law you apply here is the bullying trick. Yeah. So this X is gonna go there. And what is it gonna do? It's gonna bully the 2 there. And now we're gonna have 5x minus 6 this side.
Yeah.
Yeah. Take everything to the other side. You have 0 is equal to x squared minus 5x plus 6. Okay.
That's how. Okay.
Now you can proceed from there.
Do I move the 6?
So now here, you have to factorize this. So this here is a quadratic
Oh.
quadratic
Oh,
equation. Yeah, that's fine.
Oh. Okay. Okay. I remember that it was. How was it?
So can you remember how to solve a quadratic?
I think so.
Okay, good.
Can you hear the helicopter?
Yeah,
Oh, sorry.
that's okay. Is there something happening there?
No, there's just always helicopters in my neighborhood.
Okay.
Yeah.
Okay. No, don't
Oh,
worry. It's not disturbing me or anything like that. As long as
okay.
you're not being disturbed by it, that's fine.
Oh, no, it's fine.
Because you're used to it, isn't it? You're now used to the noise. That's okay.
Yeah.
That's fine.
5x is going to be equal to xy. Then x multiplied by and dun, dun, dun. Ooh. I remember, but I don't remember. I don't know how to
That's
explain
okay.
it.
That's okay. So I'm going to give you an example here. So normally where a quadratic comes from, we are going to end up with, because this is to the power of 2. So that means we're looking for something that's going to give us generally 2 solutions. Because if this was 3, then it would be 3 solutions, 4,
Yeah, so
4
it's x.
solutions. Okay, good. So imagine the way these quadratics come about, you normally have 2 brackets. So imagine we had x minus 4 and we had x plus 3, 2 brackets,
Mhm.
and we expand this. Yeah. So each of these terms are going to multiply. This is going to give us, well, that term, x squared. This here is 3x. This here is minus 4x. And this here is, oops, minus 12. So the final answer is x squared minus x minus 12. Now imagine I gave you this thing here. How can you go from here to these 2 brackets? That is what we're
I
going to
remember
try
it
and
was
do
like
with
2
this.
lines.
Sorry?
I remember that you taught me this. I'm sorry, I have
Yeah, no,
to
that's okay.
remember.
That's okay. That's okay. Sometimes we need to hear things 3 times before we really can remember them. So don't worry, it's okay. So what we do
You
here,
drew 2
the process
lines.
is you
Yeah.
find 2 numbers, which
Mhm.
when you multiply them together, they give you minus 12. So we're going to look for 2 numbers that multiply to give, oops, minus 12. But those 2 numbers must add. So in other words, there's a 1 here in front of this x, but I didn't put it there, but there is a 1. Those numbers must add up to minus 1. The same 2 numbers must add to give minus 1.
Oh.
Okay? And now what you're going to find is that you're now going to be thinking in your head, okay, I've got 2 numbers, which if I multiply, they should give me minus 12. But those 2 numbers, when I add them, they need to give me minus 1. Now, with a bit of trial and error, you then notice or you find that those numbers should be minus 4 and 3. So to break this apart, you're going to write firstly, this thing is now going to be written in terms of x squared minus 4x plus 3x minus 12. So can you see I've rewritten this equation into this form. I'm using this minus 4 and this 3 here because this part here gives me minus x. So I haven't changed it. It's still x squared minus x minus 12. Can you see that?
Yeah.
Very good. And this is where the magic now happens. What are you going to do? You're going to draw a little border line. Then you're going to factorize this part. If you factorize this part, this gives you x on the outside and x minus 4. You happy?
Mhm.
And then you take this x minus 4, this thing in the brackets, you're going to write it on this side of your border. So you've drawn a line here to divide things. So you're going to write x minus 4 this side, brackets, and then you got to say, what number do I need to put on the outside so that when I expand this, it's 3x, it becomes 3x minus 12. And you see that that number should be 3 on the outside, plus 3. 3 times x is plus 3x, 3 times minus 4 is minus 12. So the two brackets, if you're going to split this apart now, the final step, you are now going to join this together, this and this plus 3 are going to form one bracket, and this x minus 4 will be the other bracket. Now you can write this as x plus 3 brackets, this is the x plus 3, multiplied to x minus 4. So we've broken it. Can you see that?
Yeah.
And it's the same thing we do here. So for the next step, I just want you firstly to find out what these two brackets are for this equation. Have a go at that.
Okay, so it will be, what was it? X over 2, 5x minus 6. Okay. It can be 3 and 2, but it cannot be plus 6, right? Because
You're right. So just take your
it's
time again.
minus.
This is where you just need to think of the numbers carefully. Sometimes both the numbers can be negative. Sometimes one of the numbers has to be negative.
Oh, of course. Yeah.
Just like
that
what we
makes
did
sense.
here.
Okay. So is x minus 3
Very good.
and x plus 2.
And x, it can't be plus 2 because minus 3 multiplied by plus 2 doesn't give you plus.
Oh, minus 2, sorry.
Thank you, good. Now, I'll give you a quick other trick as well. Very, very quickly, won't take long.
Yeah.
If
I'll just
there's no
shortcut.
number in front of this x squared, like this, for example, there's no number in front of the x squared, just like here, there was no number in front of the x squared. It means those two numbers that you find, if there's no number in front of the x squared, remember Sayaka, the two numbers that you find, the moment you find out that minus 3 and minus 2 are the ones that give you minus 5 here and plus 6, you can quickly put them in the brackets without doing all of this. So you can cut out all these steps here.
Oh.
You can cut all of this out. As
Any
long
number?
as you just find out those two numbers, you can cut out all this step as long as there's no number in front of the x squared. So the coefficient of
Oh.
x squared must be 1. If it's 1, you can quickly do it, just like what you've done. Very good. So now this here is equal to 0. So what should the values of x be now? Either x is equal to 3 or x is equal to 2. That's the values for this. Either x is equal to 3 or x is equal to 2. And that's the final answer.
Oh.
How did we work out that x is equal to 3? Well, when you put 3 here, 3 minus 3 is 0. 0 multiplied to anything gives you 0. And you've put x as 2 in here. 2 minus 2 is 0. 0 times that bracket gives you 0 again. So these two values of x satisfy the equation. Did you follow that?
Yeah.
Good. Excellent. Okay. Ooh. Ooh, dearie. Sorry. My laptop was just about to die.
No,
It
it's
was
fine.
plugged in. I panicked because normally when my battery is not very good, so the moment it just shuts down a little bit, it gives me 5 seconds to plug it in, and if I don't plug it in 5 seconds, it just goes. So I've managed to get it, so that's fine. Yes, here's one with natural logs. See, oops. Okay, now have a go at this one. You're going to have to apply the rules here. This is a little bit more involved than what you've done so far.
Oh, wow.
So, yeah, so just think a little bit nicely about this one here. Let's move this here.
Do I use calculator?
Yeah, definitely. You can use a calculator for this one.
Okay. Oh, in the form of 2ln.
Yeah, correct.
Oh, then calculator is not useful.
Calculator is not very useful. Yeah, thank you. You're absolutely right. Calculator is not so useful here.
I thought, oh, okay, that makes more sense. Okay. 4ln 2, 1, 3, 3ln 4. After this exercise, can we talk about stuff?
Oh, yeah, definitely.
Thanks. 2ln b. B can be anything, right? Okay, yeah, okay. Integer to be found.
Correct.
I started doing it in one way,
Yeah.
but the answer would be in log and not ln. So
You can just change the log to ln.
how?
Because this, the same thing, oops, same thing you would do. You can think about this simply as 4 log to the base of 10 of 2. This is 3 log 4 to log 3. So all the
No,
same.
it's log E3.
Yeah, this is to the base of e, correct? And that's what natural log is. You're right.
I can just change it to log.
You can. So remember, so if I had,
Yeah, I did
you
it.
know what I mean? Like
changed
if you
it
had
to log.
a, whatever, if you had natural log A plus natural log B, this, you just use the same law, natural log of A times B. Just as you would if this was log A plus log B, it would be log A. So it's the same rules. You just change and you use ln.
If you have like log 2 plus log 3, can you just put log 5?
If you have, no. So we need to use the rule. So log 2 plus log 3 is the same
Oh,
as
right, there's a rule
log
about
of
that.
2 times 3.
Oh, right. And if there's more than that, it's just AB multiplied by C.
Yes, like the one we
previously?
did before, just like this one which you saw
Oh,
before.
okay, that
Oops,
makes
no,
sense.
no, where is it? This one here.
And
Remember?
the 2, the 3, and the 4 that are like next to each other,
Yeah,
like the 4, 3, and 2.
yeah.
Can I just add them?
No, you can't do that. So if I show you, so if I had here natural log of 2 plus
Mhm.
natural log, do you mean like this?
No. Like, do you see the before is antes? Yeah, the number before ln.
Oh, yes,
The
this one, yeah,
4.
correct.
Yeah.
So
Can I
let's
just
write
add
it
it?
out. No, you can't.
Like 4 and 3 and 2.
No, you can't do that. No. So let's just use the laws gradually. How else can you rewrite this here?
ln 2 on the power of 4.
Very good. That's exactly what you want to do first. That should be the
Oh,
first step.
I did it, but I thought it was wrong.
No, no, no. That's the first step. Can you continue from here now?
Okay. And can you add the powers?
No, you can't.
What is the law of indices? Wait. I have it. Wait a
Good.
second. I annotated it. Okay, yeah. Also, you can only add it when you're multiplying.
Now, like this, now, Sayak, at this stage here, you're absolutely allowed to now say, this is the same as natural log of. Now you can multiply all these things because now you can use this rule. So this is 2 to the 4 times 4 to the 3 times 3 squared. Yes, absolutely.
So, okay, that's smart. Yes.
Good.
And you can just multiply the ones like below, and the powers you just add them, right?
Now, I know it seems tempting to do so, but remember the laws of indices. I'm going to remind you, a times m, a to the power of m, multiplied by a to the n, multiplied by a to the, let's use another letter, s, is the same as a to the power of m plus n plus s. But these numbers have to be the same.
Oh,
This has to be the same number. It's the only time you can use this rule. If these numbers are different, you can't add them.
then what do I do?
I know, this is where now you need to try and
do I
think.
just solve them like individually?
The problem you're going to run into if you try and solve them individually, they've told you that they want it expressed in this form.
Ah, right. Then I just divide it into 2 and put 2 there.
So do you divide it by 2?
Like solve them individually and the answer divided
Yeah,
by 2.
you can do that, absolutely. You can solve them individually, 2 to the power 4, multiply everything, and then find out what this is, and then think how you can express it in terms of 2 natural log of b. You can do that. That's one way of doing it. Yeah, certainly.
Do I do it like that?
Yeah, go for it if you want to try that way.
2, 4. Oh, so it will be 2ln and brackets 44.5?
Not quite.
No?
Not quite.
Everything would be 89, right?
Not quite.
Huh? What?
Mm-mm.
Oh, wait, no. Oh, yeah. Wait, how?
Okay, so just be mindful that 2 natural log of b is the same as ln b, or natural log of b squared.
Oh. Oh. Missing this. This is oh. So wait. But you said that we cannot put them all together because they are not the same.
Yeah, I know. You can't just add these. So you can't say 4 plus 3 is 7 plus 2 is 9, and then say that it's some number to the power of 9. You can't do that. So we can't add these, but there's something we can do, Sayaka, and I'll help you out here, because I can see that you've hit a little bit of a wall. So we need to get over it. Yeah. So if we look at this here, this is 2 to the power of 4 times, well, 4 itself can be written as 2 to the power of 2.
To the power of 3?
To the power of 3, correct.
Oh, wait, there's a rule about that. Wait. It is gonna be 3, no, 2, and the power is 2 multiplied by 3.
Yeah,
oh, yeah.
And this here I can rewrite as well. I can rewrite this 2 to the power of 4 as, oops, pen. I can rewrite this as 2 squared to the power of 2. Do you agree?
Yeah.
Good. We're getting somewhere here now. But this also, this 2 to the power of 2 to the power of 3 can also be written as, we can swap the numbers. In other words, I can rewrite this as, I can rewrite this as 2
to the power of 3,
to the power of 3, and then a 2 outside. It's the same thing. Are you okay?
Yeah.
Now, can you see that there's a squared now out here? There's a 2 squared, squared,
Oh,
squared. Now I can take everything out and I can say natural log of 2 squared times 2 cubed times 3, and then a squared on the outside.
oh, oh,
Yeah.
oh. And that all of that will be B.
Correct. All these now are B. And then I can go on and say this is now 2 natural log of what's 2 times 2 is 4. 4 times 2 cubed is 8 times 3. So 8 times 4 is 32 times 3 is 96. So that's your answer.
Wait, where did the 2 come from?
This 2 here,
Mhm.
it's from here on the outside.
Oh,
took it down here.
okay. Yeah, that makes sense.
Okay. And then we did the 9. Then what was left inside gave us 96.
Oh, okay.
So that's your final answer.
Yeah, that makes sense. So
Okay. But
yeah.
what you're finding out is that the more you're doing these things, the more you're getting experience, and it will be really good afterwards. I'm going to try and send you some more problems that you can go through, just a
Yeah, I
few,
would
not a lot,
appreciate that.
because I know you've told me that you've already got you've been given quite a lot of work already, haven't you? Like
Okay, so
exercises.
my teacher usually like gives out very easy exercises at first, and you always feel like you understood it and you're happy that you understood it.
Yeah.
And he always makes such a big jump from like the very easy ones.
Right.
Right.
And that can be very difficult because you're only just learning it. He's been doing it for 20, 30 years.
Yeah, and he gives it to us and we ask him questions, and he always tells us that we already did exercise about it. So he doesn't answer our questions, and we never know what we are doing. So I was really confused.
He's a very tough teacher.
Yeah, he always tells us that looking back, that he always looks back and
Yeah.
hates the math teachers, that we are gonna do the same for him.
Yeah.
That's what he always says.
Right. Oh dear. But you see, the good thing about you, Sayaka, is because you're studious. So you know, even though, and this is perhaps something that I can bring into some of the discussion points I was going to give you here as well. Hold on, let's just go there. So one of the things you want to do really is at this rate, I know that you've got a lot of work because you've got so many subjects. It's not just maths and physics you're doing. How many subjects are you taking at the moment out of interest, actually?
Oh, well, honestly, even if I tell you, it won't be useful because I am ending the course in 2 weeks.
Oh, you're ending your course in 2 weeks.
No, okay, so I am ending MIP.
Yeah.
On like 2 or 3 weeks. Yeah, 3 weeks actually. Like this is the 3rd week.
And then you
No,
start,
I mean,
and then after
yeah.
this, you're going to be going into your IB course.
I'm already on IB, but
Yeah.
IB MIP. Next, I'm gonna do IB DP.
Correct. Okay, got you. I've absolutely got you. So would that be in 3 weeks' time then?
I mean, after vacation, I suppose. Yeah.
Oh, you're gonna have, yes, of course, because I didn't know whether I don't know what your terms are like at your school and when you'd be having your vacation. That's absolutely fine. Okay, so you're gonna have a bit of time because you know what subjects, what topics you're going to be covering.
Yeah, I actually have them. I can send them to you if you want.
Can you do that, please?
Yeah.
And let's just talk around some of those elements. Yeah.
Yeah. So the thing that I've been worried about is that I have, and even if you tell me about it, I will accept it because I know I have a terrible foundation. Like terrible. It's sad. It's even sad to look at. It's just sad. So I have no idea how I'm gonna do math AHL when I don't like, I can understand things, But my foundation is so bad that I have to just go back first and then do it.
Okay, okay. So what you need to do in this case then, Sayaka, you need to do something called skill mapping.
Okay, I'm going to annotate everything you say. Just wait a second.
That's absolutely fine. So if I go here, I'm just going to bring something.
Okay, I'm sending you the topics.
Great, good stuff.
You sent it to me and I was checking through it, but I don't understand anything that is in there. So I was just like, oh, okay, that's interesting.
Oh, there we go. It hasn't yet arrived. I'm just going to refresh. Sometimes it takes a bit of time.
Yeah, there's a lot of files, so.
Okay, okay. Yeah, sorry,
you get them?
I'm still not yet. I'm still waiting for it. So I'm just waiting for it to come through.
Oh, wait.
It's okay. It's gonna arrive. It will arrive eventually.
No, wait a second. Maybe I'll just send it.
You know what you could do? You could also send it via the chat. If it's a PDF, you can just send it via the chat. It's much quicker.
Yeah, it's just loading.
Okay, that's fine.
I had no idea you could send things from the chat.
Yeah, it's much quicker. Sometimes I forget as well.
Okay, let me try that. Oh, do I send them individually?
Yes, you can. Yeah, you're gonna have to send them individually. Unfortunately, sorry.
No, it's fine. I just have to remember which ones I put. Okay. Okay, so yeah, I've been worrying because okay, so my teacher, right, my new teacher, I suppose, I've been talking to him, and he seems nice and he seems like a good teacher.
Yeah.
But the things that he say, I mean, like stuff like, yeah, it's a very tough course, the worst course in DP. If you're taking it, just take very easy ones. It's just been scaring me. And honestly, I'm taking it with 4 people. Only 4 people from my entire class are taking it.
Wow.
I'm taking it with Xavier, who's a genius. So I don't even
told me about Xavier. Yes.
No, like he really is a genius. He's like 13 and he's in my course.
Wow.
And he's smarter than everybody. He's just, I don't think, no, he's just insane.
And you know, you're gonna have people like that who literally they get things in seconds.
Yeah? He's so stressful because he talks all the time and he always gets good grades.
Yes. And and in a bit of credit to him in that no, I say credit, I was a bit bad like that as well, which wasn't good, but I'm gonna tell you, because I told you, remember that, because I used to learn things already. Yeah. So when I got into class, I knew the topic, so I didn't feel like I needed to listen a lot. So
yeah, oh my God, so, I wouldn't mind if he talked, but he always talks to us.
Yeah, which is not cool. Because he's on a completely different page
level.
I know, exactly. And you know, I'll be very, you know, the thing is, it's good to have friends like that. I'll be very, very honest, because some of the students I teach, Sayaka, they are so bright. By the time I'm solving something on a piece of paper in 5 lines, yes, they do it in their head
in
without
5 seconds.
a calculator. And I go, how did you do that? And then I go, oh, well, I just thought about it like this, like that, like that, like that. And then I go, wow, wow, you know? So it's really good because you learn a lot. So there's some tricks you learn. So you are going to be surrounded by people who are, and I'm going to use this word, annoyingly bright. Annoyingly bright, because you're thinking, it's taken me 1 week of going to the library every day for 3 hours to get this. And I can
Yeah,
just about understand it. And you understood it in 1 minute like that. Yeah.
yeah,
So it will feel like, it will almost make you feel like, oh, I'm probably not good enough to be on this course. But what I want you to understand firstly is that
no, I would never feel like that. I just know that he's still good enough. I'm just normal.
and you are, yes, and thank you. And you see, this is the thing sometimes, I try and tell this to my students. I say, you've also got other skills that he does not have. And some of
Right.
those skills that you've got are just as important, you know. So skills from, you know, you relate well to people, you know, you've got emotional intelligence, there are those other skills that are also very important, because when you leave school, this is the reality of life. People are not going to ask you whether you did IB or what university you went to. Rarely. That will not mean a lot to people. Yes. The things that people are going to remember is how you made them feel. Yeah, that's the thing that people remember. They don't remember what you said. They remember how you make them feel. And it's developing skills as well, but being rounded. So like some of the students I teach at my school, I'm telling you, who are super bright, sometimes they don't have skills in other things. Literally, like they're so bright, you tell them a simple thing like, okay, here you go, show me if you can use a map. I want you to tell me how to get from here to there. They don't know how to use a map. Yeah. Something you're thinking, hang on, you are so bright. You don't know how to do this simple thing. Yeah. So there's always things that, you know, you might admire in people, but there's also things inside you which other people will not have. Now, I'll tell you something as well. You told me you were in a maths club with, did you tell me that you were in a maths club?
Yeah, I was in a math club. I'm still it. I am,
You're
but
in.
I guess for 3 more weeks, which is not that much.
Okay, so in your maths club, have you been mostly working on problems? Like, do you have is it just, is it students who run the club, or do you have a teacher running it?
I'm gonna be honest with you. The teacher made the club, and he is the same teacher that I have right now.
Okay.
And I don't know how, but he gets annoyed when we ask questions. So it's mostly us just talking, which is
Okay.
nice, I suppose.
Yeah, yeah,
But
yeah.
yeah,
So
it's mostly us
maths
time
club
that
is
is
good
just
because
dedicated on math.
you're
Yeah.
surrounding yourself by people who are passionate about the subject. And when you surround
Yeah.
yourself with people who are passionate about the subject, that passion rubs off as well. And you'll be learning other skills. Now, in terms of skill mapping that you need to, or we need to actually, I should say that, I'm not going to say you need to, I'm going to say we need to. We need to think
Next time
about
we can see you.
all the core areas that are going to be fundamental to you making a success of the IB course. Yeah. So what are some of these skills that you need, firstly? And then what are some of the skills you think you are lacking at the moment?
I definitely need to learn, like, well, I already know, but like make it better.
Okay,
Factorizing,
good. Let's write that down.
roots, maybe powers. I know powers, but the rules, they just make me dizzy.
Factor. Okay, that's good. But at least it's good to have this because we're reflecting on what elements we can place some focus on prior to you starting your course, especially things that are going to be necessary. Because I've been looking at the documents you've sent me for your course, and I've been looking at the calculus here.
Oh my God, calculus. Oh, that is so
Calculus.
scary.
Don't be scared that you're gonna get it. I'll make sure that you get it. Okay. Don't be afraid.
Okay, thank you. Okay, so in the math thingy, I'm with 4 people, right?
Yeah.
And that's counting me. That's me,
Mhm.
Xavier,
Yeah.
who doesn't even count. He's probably the teacher.
Yeah, about Xavier. Xavier is just annoyingly bright and
exactly.
he's in his own league.
Yeah, Aziz, who thinks he's Xavier, but he's not Xavier. And Sudina, who is my friend. She's my best friend.
Okay.
And we both don't understand anything. But the problem with Sudina is that she never does homework. So everything is there's so many different people in there. And there's only
You've got a
4.
spectrum. You've got the very bright, the I don't want to do as much work. You've got the whole lot. And I can see, but you seem to be very studious and you seem to be putting in a lot of work, which is good because I do really see that you're passionate about your work. And if you don't understand something, I know it bothers you and you don't like to be in that situation. And when you go to
study,
when you go to university, unfortunately, you're not going to have teachers like how you've got teachers in school.
yeah, imagine it.
Go and
They're
ask
not going to expect you.
questions. I know. So it even becomes more overwhelming because sometimes it's as if you almost don't know who to go and ask or to go and get help. Because now university, they don't even care if you don't come for lectures. They're not going to take a register and say, is Sayaka here today? No, they're not even going to do that. Okay. Now, I will tell you something. There are some questions I have struggled with, maths questions that I've struggled with for 5 years.
You have struggled.
Yeah, like the question, I could have gone and looked up the answer because the answers were there, but I refused to look at the answer. I said, I will try and work on this problem. And after 5 years, I finally do it. But every day it bothers me a little bit. How do I do it? How do I do it? And I know I've got smart friends I can go and ask and say, hey, how do I do it? How do I do this? And they'll show me. So there are times when it's okay to struggle with a problem for a long time. It's okay because you learn.
5 years? Have you actually done that?
Yeah.
Oh.
Yeah. So I'm telling you,
that's insane.
Sometimes it's okay to wrestle with a problem and don't always be quick to find the answer, because I know you can be like, okay, I want to know the answer, but struggling and pushing through those things develop your thinking skills and you start building what we call neurological pathway. And what's also important is to understand, because now you're going to be going into university, you need to have a little bit of what we call metacognition. Do you know what metacognition is?
I read it on my INS class, but after that, I have no idea.
Yeah.
No, so it was something about learning. It was something about learning.
Thinking about how you think.
Oh. I'm probably going to see that on my TLK.
Yeah. So you need to, at this stage now, it's about saying, okay, Sayaka, what kind of learning style does Sayaka prefer? Do I prefer to look at videos and then do exercises?
Do exercises.
Okay, yeah, okay. So when I have a problem, am I better off drawing it and visualizing the problem? I
hate drawing.
There you go. So now, there you go. So now you're being honest with yourself, and this is all part of metacognition. So you say to yourself, okay, not a big fan of drawing.
When I said drawing, I just immediately zoned out.
Yes. So not a big fan of drawing. So do you visualize? So this here now, I'll give you a little bit of a hint now. So you may not be a big fan of drawing, but when
I visualize stuff while I'm learning. Is that what you're asking?
Yeah. So what I'm saying is now, so this is something you know about yourself. So what you can do now, because you know that you're not a big fan of drawing, I will let you know that drawing helps you visualize problems easier. So it might be worth
why I've never visualized anything.
Yeah, so absolutely, like even if it's a small sketch, because when you start, so you said you're gonna do chemistry, biology, and mathematics, of course, yeah?
I am doing math, chemistry, biology HL, psychology, English A, and French as S1.
Wow, okay. For your maths, and remember, depending on what subject, I'm going to give you advice for maths in this particular case, because biology uses a different side of the brain to mathematics.
I am happy about biology because I am so good at biology. That's one thing Xavier doesn't have. He is terrible at biology. I am the best.
Thank you. And you see, I told you, I said some of the skills you're going to have, because this is the thing now. Do you know a little bit about your mind? Do you know, like, do you know a little bit about how your brain is divided?
So, yeah, I want to be a neurologist.
Thank you, because of course you're doing that, the right side and the left side. Yeah. One of them sides just deals with computations. Yep. So that side is just for maths and numbers. The other side deals with words and art and pictures. So people who are very good at maths, this side of the brain is very developed, very strong, but this side of the brain is very weak for them. And you have both strong ones? I was lucky in that I was able to have strong ones. I was very, very lucky. Not everyone. Oh, so you have to be born with them. Yes, and the reason why I was lucky, Sayaka, was I didn't tell you this, but in my early years, I was rubbish at mathematics. Rubbish. Oh yeah, you told me about that teacher that told you to do one exercise a day. Thank you. So I was rubbish at maths, but I was very good at English and writing essays and stories. I was so good. So over the years, this side of my brain was very, very strong already. And I used to paint and do all these things, loads of those things like that. But my maths was very weak. So slowly I started making it stronger. Little by little, I started doing more maths practice, and then it started becoming stronger. But when it became really strong, I found that this side started suffering. So I had to try and make sure that I was balanced. I tried to make sure that, as much as I was doing my maths practice, I was also doing other subjects. So I was very, very good at biology. I was very good. Oh, damn it. You're just good at everything. I was lucky like that, but it took years. I didn't develop these things at the same time, is what I'm saying. So I was lucky that the right side of my brain, if you like, was developed. And then later on, I started spending time developing the maths side of it. But by then, because that side was already developed, it was easy to balance everything. So Xavier is a classic case of his computational side of the brain works super well, extremely well, but that side is so weak. So he can't write an essay as well as you can. Does that make sense? Yeah, I'm pretty good at writing essays. Exactly. So you're very good at writing essays. Now, I know that you're natural at that, and that's the reason why I'm saying, once we know what skills we need to start developing to strengthen that side of your computational side, once we can map those. So I know factorizing for one, powers for one. Now factorizing here, this includes quadratic equations and all that. So you're going to need, we are going to need to make this part strong, because in calculus, you're going to do a lot of this. Yeah. You're also going to be using powers. Yeah. The other one as well is, okay, powers. So we're talking laws of indices here. Laws of indices. All the laws are so, oh my God, it's just so many laws. Yeah, there's so many laws. So the best way to remember them is to try and think of what's the right word I'm trying to put it. Try and think about them synoptically. Don't think about them just as a standalone. What do I mean by that? So, for example, I'm going to just give an example here. So when you're looking at something like this, surds, e.g., root of 3, fifth root of 8, I'm just giving an example, 2 to the 5. I'm just throwing random numbers here. They look like random numbers. But what I'm trying to say here is that laws of indices are also linked with surds. So we know that this here is 3 to the power of half. What about this one? Well, this is 8 to the 5th root. Yeah.
Oh.
So instead of just thinking about them in terms of trying to also see where else you might see them hidden. So in maths, there are lots of things where things hide in other things. And unless you've really developed your math side, sometimes it's very difficult to see what's hiding. So if you remember here, when we did this question not too long ago, I'm just going back to it. I want to show you something. So you see here, there were things that were hiding until we started breaking it up. 2 to the power of 2, 2 to the, so things were hiding. So it's about being able to train your eye to start spotting where things are hiding and uncovering them, okay? So this is what I'm saying, as just thinking about it synoptically. The other thing as well, Sayaka, that really helps, especially with what you're going to be doing, so is to find, like, if you look at especially for something that you're struggling, yeah, try and also make your own questions. I used to do that. Yeah.
That sounds smart, because you have to think about the answer and also
exactly. And I tell my students, I said, sometimes it's good to make your own questions, because then you stop thinking like a student, you start thinking like a teacher. And so you want to train yourself.
So you can think also about what the teacher wants when you're answering a question.
Thank you. Exactly that. Okay. So make your own questions, and in making your own questions, you're going to remember things a lot more, because you're going to be like, okay, what should I think about here? Then you're going to be thinking to yourself, okay, I've seen a challenging problem. Can I change the numbers and see if I can make something similarly challenging? So here, I'm just giving an example. Literally, I'm just giving an example. You can say, right, so what about if I change this? And you can start getting things really to an exciting level, like, almost to the point where you're thinking, is it possible to solve this? So you might put something here, 4 natural log of 2, and then here you might throw in something like, you might throw in a normal log, log to the base of 2. Yeah, I know. And then say, is it possible? Now, of course, the question is not going to be 2 to the land b. You're just going to throw things. How would I solve it if it was like that? So this is log to the base 2, and that was natural log, and this was log to the base 10. How might I do something like that? It's just...
Oh, log to the base 10 is always going to be log.
Yes, it's always going to be log, yes.
Oh, awesome.
Well, you're right, yeah, because your calculator only works in base 10 anyway.
Yeah.
Automatically, your calculator works off in base 10, okay? So this is another part I'm going to tell you here. Make your own questions. Now, this is the reason why I was saying, are you still part of the Maths Club? Because the Maths Club is a nice place to make questions and then say, guys, I've made this question and this is the answer. What do you think? And then your friends can come in and say, yeah, we can even make it harder. Why don't we change that part of your question and add this? So it's those things that are also going to help enhance your understanding of the topics. Okay.
Okay.
But I know Maths Club is only going to be for another 3 weeks, so I'm not going to talk about Maths Club too much. Unfortunately, that.
No, maybe we can have another Math Club on 11.
Maybe, yeah, absolutely. So the other thing,
also,
I'm just quickly doing back to still this mapping in terms of the skills. Where are we?
Oh, but can I ask you a question first?
Go on.
Okay, so right now I'm studying like not that much. I'm studying like 3 to 4 hours a day.
Okay.
But I would do more, but I don't feel like doing it because that's what I can, like, it gets me good grades with 3 to 4 hours.
Yeah, you get good grades 4 hours.
But, is that every day? Huh?
Is that every day?
Yeah.
So it's not too different from what I used to do as well. Go on. Yeah, about 3 to 4 hours.
So I asked around, and I asked teachers, I asked coordinators, I asked students that have the same, like, I asked a student that has biology, chemistry, like the same ones with just one of SL of difference. So it's mostly the same.
Yeah.
And they just study like way more. And I expected that because I'm doing MIP, obviously it's gonna be different. But
and yes, I see. So you almost feel like maybe you should be doing more, but you see, Sayaka is not even,
for
it's not,
DP,
it's
they
not even
do
about
7 hours on
wow.
every day, and on weekend they do like 10 hours. And I can do like 5 to 6 hours,
Yeah,
but I don't know how I can focus for 7 to
I
10 hours.
absolutely, and I hear you. Okay, now this is what I'm saying, that
How do you
later on in
focus for
life you
that
have
long?
a little bit more to say. It's not about working hard, it's about working smart.
Working smart.
Correct.
I
Now,
have seen that on Facebook, I think,
absolutely, well
or
done.
Instagram.
Absolutely. Now, I have people in my class who I teach who, even during lunchtime, they don't have lunch. I see them, they come to my lab and they work through lunch, and I'm always seeing them. Oh, like they come in the morning at 7 o'clock, 2 hours before school starts, they're in the library, but their results, when the test comes, is nowhere near what I think or how I think they're going to, because you think, oh yes, they're doing so much work, they're going to do very well. When the exams come, they don't do well. So sometimes I have conversations with them and I say, look, I know it must be very disheartening for you because I see you working so hard. And then when the exam comes, the results just don't match with the work that you're doing. So what is it you're doing? Let's try and work out a solution, because you can't be working hard and not getting any results. So
No, I know, but
I'll tell you now something. 3 to 4 hours is a good amount of hours to put in after school. It's how you're going to do it. If you're going to sit on your desk for, say, 3 hours straight.
I always do 50-10, like 50 studying, 10 minutes rest.
Thank you. Good. That is exactly what I was going to say. I was going to say you are going to overload your brain. 50 minutes is a good discipline.
More than that, I feel like everything just goes away.
But you see now, the thing about it then, Sayaka, this is how it works with concentration. Concentration is like this. Concentration, it's called a bathtub curve. Yeah. So if this is time and this is level of concentration, it does this.
Yeah, I kind of guessed that. Oh.
Yeah.
Oh, I did not guess that.
I know. Okay. So it looks like a bathtub. Yeah. So in the first 20, 30 minutes, yeah, your concentration is at the almost, well, it's dwindling, but it's still fairly high. After that, into 40 minutes, does this. Yeah. And then, so this time here is about, I should have put time. Okay, I'm drawing graphs now. This is becoming very mathematical. This here is 0. This is 0 to 40. Okay. This is 40 to 50. This is
10 minutes.
60. Okay, minutes.
Oh, so not that much. I expected like 1 hour or something. Oh,
no.
So only 10 minutes of low concentration.
So the best opportunity you have if you want to learn anything and you want to make the most practice while you're learning is in that first 40 minutes.
Oh,
after that, it becomes very difficult to concentrate unless, so it is at this point now, when your concentration is low, that you now need to do something to boost it up again and bring it up. Now, a good thing to do, so if you've been doing a maths problem, you can do 3 maths problems. You say, okay, I'm going to work on factorizing today, and I want to do some challenging problems. When you get to that point, you can now either, do something completely different to switch off that side of your brain. You can then say, right, I'm now going to do Arrhenius equations from chemistry. Just do 1 or 2. Now you can go back to your maths again for another 10 minutes, even 15 minutes, and your concentration will be shooting up again.
Oh, okay, that makes sense.
Absolutely. So it's a way of how the brain processes things. Now, undoubtedly, again, the more active your revision is, so it needs to be active. Active.
Like constantly.
No,
But
I don't mean it like that.
oh,
It needs to be active. It needs to be creative, and you need to try. Like, remember what I said? I said you will remember things easily if during the time that you are learning them, there was a certain feeling, a good feeling you had while
oh,
learning. You will remember it much more often. So what do I mean by active revision? There are loads of things you can do, especially for something that, I'm giving an example. When I used to do biology, there's lots of essays to write. Yes. So what did I used to, and chemistry as well. There's lots of facts to remember. I used to make little songs.
oh,
Yeah, we're gonna have
like
some fun today.
Soccer.
Let's write a song. Let's make a song. Yeah, like, because I know if I don't make it fun and it's not going to be a happy time, I'm gonna find it very hard to remember that. So I used
Oh,
to do, and you try and create different ways of looking at things. So sometimes also what you can do in active revision is you can say, okay, I'm going to take the answers. So just looking at the answers from a maths question, I will
and
make
create
the
a
question.
question.
Yes.
Oh,
So
that
these are
is
the answers.
so.
What was the question? So that's active revision, because you're thinking about things. You really are putting every minute, your brain is thinking about something. You're not just taking information, you are processing and you're trying to interact with the work.
That makes so much sense.
Yeah.
Oh,
And
also,
ideas you can have. So for example, so I've given you here an example where I've said, answers questions. Another thing that's really, yeah, go on. Sorry, Saka, you're about to ask a question.
oh no, it's just remember when you say working hard and working smart?
Yes. So working
I
smart,
know it
you
sounds
go on.
like I know it sounds like they are not working smart, but everybody just studies that much. I don't know why. They always say like you cannot do like good grades if you
Mhm,
work any less. Like if they study like 7 or 8 hours, they
mhm.
get like top marks.
Yeah, but I think that that is not sustainable in the long
Yeah.
future, because by the time they go to university, they will be burnt out. They will be burnt out because they've used so much of their energy in the early years, have not paced themselves appropriately. Those hours that they're talking about, that's what you do in university.
You
But
cannot
if
do
they're doing,
both.
if they're doing 10 hours after school, that's what I used to do in university, not when I was in school. So remember what I told you. I said I used to, the earliest I used to, my plan, I'd be in bed by from about 8, and then you wake up at about 1. Yeah. So I've had 5 hours sleep. And then I'd work from 1 till about 5. So I do 4 hours work before school starts. And then I do some karate, do some fitness or whatever. Or if I'm very tired, I give myself another nap and I'll sleep till 6. And then after 6, because school used to start slightly later, about 9 o'clock, then I've got other activities to do. But also the school I went to, they used to put us through fitness regime. So we had to do lots of swimming in the morning and running and all sorts of things. But that was my regime. So I'll do 4 hours then in very, very early in the morning. Then when I got back from school, we finished school about 4. So by the time I had dinner, saw my friends a little bit, I probably didn't do more than an hour's work later in the evening. So I'll probably work from like 6 then, or 6:30 till about 7:30. So even then, I was only doing 5 hours a day at the most.
Oh,
At the most, I was doing 5 hours a day, but on an average day, I was doing 4 hours. So for you to tell me that they're doing 10 hours, that's like, whoa, that's a lot. That's a lot.
yeah.
So don't worry about it. This is what I'm saying. Make sure that your revision, your learning is active. It will be more effective than you thinking, okay, I need to sit down, because how long you sit down at a table does not equate to how well you're going to do. It's about that smart element in interacting with your work as best as possible. So what I think I'm going to do, Sayaka,
Yeah, I think I just saw your
I've got
turn.
some ideas in terms of some of the skills I definitely know you need to work on in
Yeah,
your,
thank you. Can you send me a list?
yes, I'll send you a list. And
There are
then,
so many things that I don't know that I don't even know the name of.
yeah, you know,
So I don't even-
I'm gonna send you a skill set list, okay? And then we're going to rank it in order of which one are you most weakest at, and then we're going to start working on the most weakest skill.
Yeah,
Does
yeah,
that make
that would
sense?
help.
Yeah,
Thank you so
absolutely
much.
fine. That's absolutely fine. But don't let them scare you if they're doing 10 hours work. You're
Oh,
doing
they scare
what
me
you're
so
doing.
much. Every single person is like minimum 9 hours. Oh my
No, no, no,
God.
no, 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 no. Don't work at your pace, okay? And I think you're working at a good pace. If you try and do more than this, my fear would be that you're going to get burnt out, and then when you get burnt out,
How long does burnt out last?
it can last from 1 month to 3 months. So this is where literally your body will just go, your mind will go, I need a break. And it's better you pace yourself slowly, gradually. And I know, of course, look, in Japan, there's
It's
obviously
so tough here. Oh my God. Oh, it's
in
so
Japan,
hard.
there's a culture of very hard work and very serious.
Imagine IB in Japan.
Yeah,
It is so.
it's
You
difficult. I
study
know,
3 hours and 4 hours and they criticize you. Oh my God.
I know. So I know that, yes. And you know, you were in Mexico before, and you know, you've lived
Yeah.
around. So
Oh my
you're coming
God.
from a
I
very
studied 1 hour
different,
and they were surprised.
I know. So you're coming from a different, so it's been a bit of a culture shock for you, you know, if I can use the word, in
Mm.
terms of the education system and how much work everybody's putting in. But don't be disheartened, or don't feel that you will not perform well because you're not doing 10 hours a day. No, I disagree. With 4 hours work extra after school, you can get a decent grade. Now, there will be times, obviously, Sayaka, that you might have to do 5 hours because you've got more assignments. That's okay.
Oh,
But
it's
this is
fine. I
this
can
is a
handle
good
5 hours.
average. Sorry?
I can handle 5 hours. I'm not so
Exactly.
sure about
Exactly. So there'll be times when, now, if you're doing 10 hours a day, what about the day when you're going to need, you're going to have extra things to do? How many hours are you going to put in?
13.
Yeah, I know. And then, you know, but you're a human being, and you need to understand that, you know, it's better to have a balance than to be extreme. In the long run, you don't go as far if you're being very extreme. Now, it's different, of course. Like if you're absolutely passionate about something, like you love it, you
I
find
love
you can you
biology.
can you can do it for 10 hours without even realizing that 10 hours has gone past. But if it's something that you're only developing and you know it's not your strongest thing, this is good. Don't punish yourself by sitting there for 8 hours. Don't. It's
Yes,
my
I kind of needed to hear that.
Yeah,
Yeah,
no, 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 no.
so
Yeah, I'm absolutely telling you right now to say the extra 6 hours of work that they're doing is not giving them a much bigger advantage than you who's doing 4 or 5 hours. I'll tell you that.
okay, I'll believe you, teacher. I'll
Good.
believe.
Okay. I'll send you the skill set.
Yeah, that will
And
help.
then can you take some time to think about, because this is where I'm going to need your help. You can tell me which of those things genuinely you think this is my weakest, followed by this, followed by that, followed by that.
No, it's fine. I know my weak points, so that will be easy.
Good. Excellent. So I'll send you this. And I said I will send you 2-3 extra questions on logs, just so you practice. With logs, there's only one secret, and that secret is practice, 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 practice.
Okay.
Yeah.
I'll do that then.
No problem, Saka. Have a lovely, lovely evening.
You
And
too. I'm sorry, I stole like 5 minutes.
that's okay. You had a bit of a break. You had to you remember when you had a little bit of a break that time. It's okay. We've added that time on. Cool. So do you want to let me know when you might want to just drop me an email 48
Oh,
hours?
also,
Yeah.
How many do I have less? I'm sure
Yeah,
that
so
I should be
did you see
starting
the email
paying
I
again.
sent? Did you see the email I sent where I put in
Yeah.
Alex? And so they're the ones who your money was paid to. So I don't know how much money you paid. So then they know how many lessons are left. But because
I'm
today,
pretty sure I haven't paid for like 2 lessons now. And I don't know because I have no idea.
yeah, so I emailed them, as you saw in the email, and no one has gotten back to me because they're all on holiday. Because today in England is a holiday today. The
Then I'll
celebrate.
tell my mom to pay and then we'll see.
Yes, exactly. That's fine. Thank
Because
you.
I'm probably sure I'm just not paying you at this point. So
Yeah, no, I haven't, look, I haven't been paid for the last 3 lessons I've had with you.
oh my god, really? Okay, I'll tell her to
Yeah.
pay.
No, but that's fine, that's fine, that's fine. We're gonna sort it out. Don't worry, okay.
I am just so confused about everything.
Even
So I'll
even
just tell her.
you know what, I'm a bit confused because of course you're in Japan, so it's the way they're dealing with the money side of things is different to how I deal with students who I teach in England. So there was an
You should tell
arrangement
me, teacher,
because
when I'm not paying you. Oh my god, you didn't tell me
no,
anything.
don't. That's the reason why I have. It's only the last 3 lessons, Sayaka. The other
Okay.
lessons I have been paid
3
for.
double lessons or 3 lessons?
3 double lessons.
Oh my god, so 6 lessons.
Yeah.
Oh my god, teacher, how dare you?
Well, that's why I emailed them, but that's gonna be sorted. Don't worry. It's gonna be sorted because today they're celebrating the Queen's. There's something to do with the Queen in the country today, so it's a holiday
Oh.
today. So
Oh.
that's the reason why I haven't heard from them. But when they get back to the office, maybe tomorrow, I think they're going to let me know, and they're going to let you know, and everything will be sorted. Okay.
Okay, yeah, you know what? I'm just telling her to just
Okay.
pay you. I'm
Okay.
sorry.
Thank you. No problem. Say,
My
say, let
apologies.
me know. Drop me an email when you want your next lesson. Okay.
Thank you. Bye.
Welcome. Bye now. See you soon, and all the best.